Hello. Today we're going to be doing curve sketching rational functions. So we're going to be taking a look at how to solve for the VA, the HA, the x-intercept, the y-intercept, the critical points, the POI, the behavior around the VA, and the sketch or graph. So it's going to be a lot of talking, but it's information that you'll need to learn before curve sketching rational functions. So a rational function is a function in the form h of x equals f of x over g of x, where f of x and g of x are polynomial functions. Here's our checklist right here. As we can see, we have vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts, critical points, POI, behavior on VA, summary, and sketch. Moving on. So vertical asymptotes are the zeros of the denominator, or g of x. So we set the denominator equal to 0 and solve for x by isolating x or factoring. So g of x equals 0 and solve for x. And the rational function gets closer and closer to the VA, but never actually touches or equals the VA. The VA is x equals a number, and that's going to be in our summary as well. Label the VA on graph with a dotted line going vertically along the x value of the VA. And don't forget your therefore statement. And this is what a possible VA looks like. Moving on. There are 3 cases that help mathematicians decide what the value of the horizontal asymptote is. So the degree is the largest exponent of the polynomial. Case number 1. The degree of the numerator is smaller than the degree of the denominator. The degree of f of x is less than the degree of g of x. Then the horizontal asymptote value is 0. HA equals y equals 0. An example would be 1 over x over x squared, x plus 1 over x to the power of 3 plus 1, things like that. Moving on. The degree of the numerator is equal to the degree of the denominator. The degree of f of x equals the degree of g of x. Then the horizontal asymptote is the leading coefficient of f of x over the leading coefficient of g of x. F of x is the numerator, g of x is the denominator. And then the HA is y equals the leading coefficient of f of x over the leading coefficient of g of x. Or, if you would prefer different terminology, it's y would equal the leading coefficient of the numerator over the leading coefficient of the denominator. So things x plus 1 and x plus 10. Then the coefficient would be 1 over 1. So y would equal 1, and that's the HA. It can be 2x plus 5 over 3x plus 6. 2 over 3, that's the HA. Moving on. Okay, the horizontal asymptote, case 3. The degree of the numerator is greater than the degree of the denominator. The degree of f of x is greater than the degree of g of x. Then no horizontal asymptote, but an oblique asymptote. You solve for the oblique asymptote by long division, dividing the numerator and the denominator. And then I did a bunch of... So here's the numerator and the denominator. You divide the numerator by the denominator and you get an oblique asymptote. And then here, the denominator is we're dividing the denominator and the numerator, and we get an oblique asymptote. So denominator goes here, numerator goes here, and your oblique asymptote will be on the top. If you need to review dividing by long division or solving polynomial, just dividing by long division. So OA, y equals OA. X-intercepts. X-intercepts are the zeros of the numerator, or f of x. Set the numerator equal to 0 and solve for x. The calculated result is your x-intercepts. Remember that the y value of the x-intercepts is 0. And let's not forget that therefore statement. Substitute x equals 0 into h of x, or the function. The y-intercept is where the function crosses the y-axis, so the x value is always 0. And let's not forget the y-intercept, therefore statement. So again, substitute x equals 0 into the function. Critical points. Use the quotient rule to find the first derivative. Set the derivative equal to 0 and solve for x. Substitute x value into h of x, or the function, to find the full critical point. Be aware that there are often no solutions because there is no way to solve for x with the derivative calculated. Sorry, I just need a minute here. Okay. So we substitute. Be aware that there are often no solutions because there is no way to solve for x with the derivative calculated. For therefore statement, outline no solutions, but it will depend on the question. So for this one, we'll use the quotient or chain rule to find the second derivative. Take the derivative of the first derivative. Set the second derivative equal to 0, then solve for x. Input x values into h of x, or the function, to get the y-coordinate of the POI. Beware that there are often no solutions because there is no way to solve for x with the second derivative. And then for therefore statement, outline no solutions, but it will depend on the question. So for checking behavior on the VA, similar to increasing and decreasing intervals in the chart of concavity, create a chart with the VA outline. Choose values close to the VA, but above and below the VA value. But above and below the VA value, you'll check to see if it's increasing and decreasing by inputting those numbers into the first derivative and the calculated result being positive or negative. You'll check if it's concave up or concave down by inputting those numbers into the second derivative and the calculated result being positive or negative. Here's what a chart looks like and the symbols you'll be using. Create a summary of all information collected. The VA, the HA, the x-intercept, the y-intercept, the critical point, and the POI. Make sure you check over your checklist. Check off your checklist as you go along or as you do the summary. Sketch your graph, proper scale, functions labeled, y-axis and x-axis labeled, VA and HA or VA an AJ or an OA labeled and dotted line drawn. Double check all work, complete checklist, highlight the graph if necessary. Label all information collected on the graphs, example x-intercept and y-intercepts. And that's everything I have for you today. Thank you very much.